Sketching linear graphs. Okay, so in order to sketch a straight line graph, we need 2 points. That's the minimum amount of information that we need in order to be able to draw a unique line. So we need to find 2 points. Now in any graph sketching, whether we're dealing with simple linear functions as we are here, or whether we're dealing with quadratics or cubics or exponentials or logs or trig functions or whatever they may be, the convention is always that we mark axis intercepts. So x-intercepts and y-intercepts. So regardless of which 2 points I use to make my sketch, I'm still going to need to calculate the x-intercept and the y-intercept. So I may as well calculate those as the 2 points I'm going to use to sketch the graph. So if we're calculating an x-intercept is the point where the graph crosses the x-axis, and we know that every point along the x-axis has a y-coordinate of 0. So by substituting y equals 0 into my equation, I'm finding for this equation, when y equals 0, what does x equal? So that's going to give me the x-intercept. And we can use similar logic talking about the y-intercept, which is the point where the graph crosses the y-axis. And we know that all points on the y-axis have an x-coordinate of 0. So we're going to substitute x equals 0. So let's have a look at a couple of examples. So the first one here is asking you to sketch the graph of y equals 2x plus 4. Now you can use the gradient and the y-intercept to make your sketch, because this is in gradient intercept form, and immediately we can see that this is going to be a line with a gradient of 2 and a y-intercept of 4. So you could use that as your way to make the sketch. So for example, we'll try that again. So for example, if I draw my axes, so y-intercept at 4, we have a gradient of 2. So a gradient of 2 means that every 1 step across, I take 2 steps up. And so the next point on my graph will have coordinates 1, 6. So I should be able to draw my line with those 2 points. Sorry, we'll try and get that a bit straighter. Okay, so that's going to give you the correct line, but you haven't marked the x-intercept, this point down here. Now you can use your gradient to step your way down to the x-intercept. So we could go from the y-intercept at 4, 2 steps down, 1 step across. This would be the point, negative 1, 2. 2 steps down, 1 step across. This was clearly the point, negative 2, 0. So it is possible to sketch your graph just using gradient and y-intercept. Now we were lucky here in that when we step out the gradient, it allows us to work out the x-intercept. But if your gradient is something a bit uglier, like 3/7, you're not going to hit the x-axis exactly, and you're still going to need to calculate the x-intercept. And I strongly advise you to move away from using gradient and y-intercept to make your sketch. Again, it's quite an immature sort of method, having to mark out dots and count 1 step across, 2 steps up, etc. It's much, much easier to simply calculate your 2 points. So calculate your y-intercept, which we can see immediately in this equation, and that's because when we let x equal 0, y is going to equal 4. And calculating your x-intercept, so we let y equal 0. Oops. So y is equal to 0. So subtract 4 from both sides and divide both sides by 2. We get our x-intercept. Mark those 2 points and draw your graph. I wouldn't draw any graph before calculating my points. We'll have a look at that in the next example, so that you draw suitably scaled axes that allow you to show all the information required. You'll notice also that I've marked the x and the y-intercepts with coordinates. That's not strictly required. You could just write the number 4 at the y-intercept and the number -2 at the x-intercept. Although at a VCE level, they're more and more commonly in the papers asking you to label the axis intercepts with their coordinates, and if you don't write coordinates, you'll be marked down for that. So it's a good habit, I think, early on to just get into always marking these points with coordinates. All right, let's have a look at the second example. So this is in a slight variation of general form. So we could convert it into y equals mx plus c, but the chance of you making mistakes in that process and then having a difficult gradient to deal with are quite high. So we don't want to use gradient as the way to sketch the graph. Calculate your 2 points. So calculate your y-intercept and calculate your x-intercept. It's actually very easy to do that with the equation in this form. So our y-intercept we know we find by letting x equal 0. So we're going to have 3 times 0 plus 2y equals 10. So obviously 3 times 0 is 0, so we're just left with the simple equation 2y equals 10, so y equals 5. And my x-intercept, we're going to let y equal 0, so 3x plus 2 times 0 is equal to 10. 2 times 0 is 0, so we just have 3x equals 10, so x equals 10 on 3. Now I'm going to stick with the improper fraction in terms of labelling the point, but I am just going to note that this is equal to 3 and 1/3 in order to help me with my scaling of my axes. So I've done all my calculations before I even think about drawing anything. So now I can see that I need my graph to be able to show a y-intercept at 5 and an x-intercept just on from 3. And so I'm going to draw suitably scaled axes. I'm not going to mark out thousands and thousands of points. In fact, I'm not really going to mark out any points. I'm just going to draw my line. So y-intercept at 5, x-intercept at 10 on 3. And that's all that's required. So you don't need to use a ruler, though if you have trouble drawing straight lines freehand, then I would recommend using a ruler. You don't need to measure out the scale, but it should be vaguely accurate. And also your scale doesn't strictly need to be consistent on your x-axis and your y-axis. So actually it would sort of be okay if your graph did this and said 0, 5 and 10 on 3, 0. I wouldn't advise it, but it's still a perfectly correct graph. Okay, so we might encounter some problems with using the intercepts in order to draw the graph when our graph only has one axis intercept. And we'll see that with graphs of this form, y equals negative 3x, or y equals a number times x. So clearly, if we think about this in gradient intercept form, this is y equals negative 3x plus 0. So we have a y-intercept at 0, so it passes through the origin. And we'll see that too when we try to calculate our x and our y-intercept. So the y-intercept, we let x equal 0, so y equals negative 3 times 0. And so our y-intercept is clearly 0. And then the x-intercept, we let y equal 0. Dividing both sides by negative 3 also tells us that x equals 0. So both the x-intercept and the y-intercept are the same point. The graph passes through the origin. So this presents a problem because we need 2 points to draw our graph, and we've only found 1 point in finding the x and y-intercepts. So in this case you do need to think about your gradient. So my graph goes through the point 0, 0, and it has a gradient of negative 3. So the coefficient of x is my gradient. So gradient of negative 3 means that for every 1 step to the right, I take 3 steps down. And so there's another point. My graph goes through the point 1, negative 3. And then I've got 2 points that I can join together to create my line. So you do need to have 2 points marked, so it is important that you give the coordinates of that second point. The origin, conventionally, we don't need to mark, but if you wanted to write 0, 0 there, it wouldn't be incorrect. We've thought about gradient in order to find this second point. You can just think about substituting any number into your equation. So here's my equation, y equals negative 3x. When I let x equal 1, y will equal negative 3. The graph passes through the point 1, negative 3. Mark that on, draw my line. Or you could use any point. When x equals 10, y equals negative 30. Mark that point. Just 2 points on your graph. Another type of equation that might only have one intercept are equations of the form y equals a number or x equals a number. We need to think about what this means. So thinking about y equals 5, again, if we think about this as being in gradient intercept form, we could think about it as being the same as 0x plus 5. So it's a line with 0 gradient and a y-intercept at 5. We've talked previously about what 0 gradient means, and it means that we have a horizontal line. So my x-axis, my y-axis, my y-intercept at 5, and a horizontal line passing through 5. So there's the graph of y equals 5. We can also think about, what it actually means. We're drawing the line y equals 5, so we're marking all of the points on the Cartesian plane which have a y value of 5. And every one of the points along this horizontal line have a y coordinate of 5. If we use that same thinking in looking at example 5, so sketch the graph of x equals negative 4, we want to mark all of the points on the Cartesian plane where x is equal to negative 4. So if we say we have 1, 2, 3, 4, so let's have x. So there's the point negative 4, 0. Here's the point negative 4, 1, negative 4, 2, negative 4, 3, negative 4, 4, etc. We could go on and on and on, negative 4, negative 4, and all the points in between. All of these points have an x coordinate of negative 4. So the graph of x equals negative 4 is a vertical line with an x-intercept at negative 4. It's quite common for students to mix these up because y equals 5, they're used to y being the vertical axis, and so that must be a vertical line. But I want you to think carefully about what it means for y to equal 5. Where are all the points on the Cartesian plane where y is equal to 5? And that will make life a bit easier for you and help you to avoid making that common mistake of drawing horizontal lines for x equals a number and vertical lines for y equals a number. So y equals a number is a horizontal line, x equals a number is a vertical line.